With us today is Dr. Osamu Tabata from Kyoto University of Advanced Science, where he is the Executive Vice President, the founding Dean of the Engineering and Graduate School of Engineering, and a professor.
Yes.
Dr. Tabata received his MS and PhD degrees in engineering from the Nagoya Institute of Technology in 1981 and 1993, respectively. Prior to his appointment at the Kyoto University of Advanced Science, he has worked at the Toyota Central Research and Development Laboratories, the Department of Mechanical Engineering, Ritsumeikan University, and the Graduate School of Engineering at Kyoto University. He is recognized as an international leader in research on micro-nano processes, MEMS, and DNA nanotechnology. Dr. Tabata, thank you for taking the time from your busy schedule to be with us today.
Thank you very much. I'm very pleased to be here, and thank you for choosing me for the interview.
You're welcome. The MEMS Technical Community is very happy that you've taken the time to meet with us today. Let's begin our conversation with your beginning. Can you tell us when and where you were born, and perhaps share some memories of your early family life?
I was born in 1956, and I born in nearby Tokyo, Yokohama, and I spent until I was 5 years old, and then I moved to Shiga Prefecture. Shiga Prefecture is next of Kyoto, and then I grew up until the end of high school. During these days, I spent 1 year at Shikoku, another prefecture, but almost continuously stay at Kusatsu Shiga Prefecture, and then from university, I moved to Nagoya, where my school, Nagoya Institute of Technology, locates.
I see. What was it like growing up in Yokohama?
Well, I have only small memory. For example, one of the biggest memory is I don't like kindergarten, and when the kindergarten bus to pick me up, I hide, and then teachers trying to find me, and finally I was catched. But that is my biggest memory at that time.
I see. So tell us more about your early school years, from primary and perhaps up through high school. What kind of student were you? What were your favorite subjects?
Well, when I was elementary school, I was a member of a kind of club of making something or inventing something. I don't know how do you say in English. And I was a member of that club from fourth grade to the end. And I'm always making something. And one of my regular habit is on the way back from school to home, I always drop by a shop selling a lot of materials or components, motors, or so on, to find something interesting and then buy and making something. So such kind of things is my hobby, and I like that very much.
It seems like you had some early inclinations to be an engineer, building
Yeah,
and
could be,
making
could be.
things. Very, very interesting. Did you and your friends have any fun activities that you would do together?
Yeah. We have, I have several friends who has the similar habit, and also I do, how do you say in English, the radio communication club, amateur, CQ, hello,
Yeah,
CQ.
amateur
Yeah,
radio,
amateur
sure.
radio. Yeah, I also got the license of that, and then communicating with my friends, and also some overseas person, because my radio frequency is 50 megahertz, so I cannot communicate so many people. But yeah, within Japan, I can communicate some peoples. That was another hobby.
That's fascinating. Can you tell us about your parents, and did you have any siblings?
My father was a university professor, but when I was the reason of why I moved to Shiga Prefecture is my father changed his job from university professor to company engineer. That's why we moved to Shiga Prefecture. So he was kind of an engineer at industry, and then he has a office study room at home, but I don't have. So I'm putting my desk on the corridor outside of the room, but he has his own study room, and that is my kind of secret place. So I often see what he's doing. I only see his back, and then he's doing something. That is my biggest memory of him. And he often make something good for the family. But I also do similar thing, but for example, making shelf of the bookshelf. But my mother always say, the shelf made by father is very good, rigid, stable. But the shelf you made is often fall down, something like that. So I always want to be something like my father.
I see. So after high school, you ended up studying engineering. Can you tell us maybe what led you to choose engineering as the topic for your college education?
Well, when I was high school student, I don't know why. I don't know the reason of why, but I was interested in a kind of field between engineering and or machine and human. So something like interface between the machine and human. So I was interested in I would like to go that direction in between engineering and maybe bio or something. So I tried to apply the department which teaching that kind of area, but frankly saying, I failed, and I chose the second option, and it is the field is instrumentation engineering. So it covers not only specific field of engineering, or for example, mechanical or electrical, but it teach all the cross-disciplinary field, including mechanical, electrical, or math and physics, and so on and so on. So, but I keep having an interest in that area between engineering and some bio or creators.
But also sensing, it seems.
Yeah, at that time I didn't clearly realize that is related to sensing, but yes, maybe sensing is also the very important part of that field.
I see. Can you tell us anything else about your time in college as a undergraduate student working towards your degree?
Yeah, because I keep having that interest in that direction, in that area between engineering and bio or some living things. So when I was fourth year grade, I have to choose one laboratory to do my graduation thesis. That time I selected the laboratory doing research on physics, surface physics, because the professor in that laboratory is very well known as a professor who is very strict on everything, including experiment and analysis and so on, so on. And students studying at that laboratory is have to study very hard. But I have interested in how the physics are and how the strict be strict on the physics is what is that? So I'm very much interested in that. So I chose that lab for the graduation thesis. But I want to go something like the more engineering and between creature or bio. So I chose the laboratory for master course of the professor who are collaborating with medical school of another university. So I chose another laboratory for when I became a graduate students. And then I asked my professor, please send me to the medical school laboratory who are working with you. And he agreed. And so I did my master thesis work at a kind of a research institute belongs to Nagoya University Medical School. And I did cardiobiology. I did my research with cardiobiologist.
I see. So when you did research as an undergraduate student, that was part of your program. All the
Yes.
students in their fourth year had to have some research
Yes.
effort, a thesis.
Yeah, in Japan it is very, very common. Fourth year student belongs to one laboratory and do a kind of initial step, the first step of the research as a graduation thesis for 1 year.
Seems like a very good idea. And you liked the challenge. You wanted to find the challenging, you said strict and
Yeah.
very, that's interesting that you embraced the challenge. So you decided after your bachelor's degree to pursue this master's course, as you mentioned. I'm sure some of your friends and colleagues left to go to industry with a bachelor's degree. Why did you decide to get a master's?
That's a good question. That time, the number of classmates of my class is 60, and only 10 of them are going to graduate school. And the reason of why I chose to go graduate school is maybe I like that. I like to do kind of investigate something. It could be research. It couldn't be research. But I like very much to try something at university. And also another point is my father, as I said, was professor. So he has a PhD, and one day he explained to me what is PhD, and maybe I was very much interested in to go deep in one field, and maybe I would like to have PhD in future, and so that's why I chose to go to graduate school, but my school only has master course, so unfortunately finally I decided to join the company after finish my master. Yes.
Yes, fascinating. Now, in your master's course work, you said you were interested in the medical field and worked with someone in the cardiac area.
Yeah.
Can you tell us more about that project? Did that involve sensors as well?
The research topic I was involved in that time is electrocardiograph information processing. Usually, electrocardiograph put about at most 12 electrodes on the body, but for the research, about 100 electrodes is placed on the whole body and take the ECG from those 100 electrodes, and then so it shows the potential map on the surface and analyze the information to extract some meaningful medical information from that potential map of the body surface. That is my research topic.
I see. Now, as you said, at Nagoya University, they only would go through a master's. And as you said, your father's influence made you think about the possibility of getting a PhD. You could have perhaps gone immediately to get a PhD, but you decided to go work in industry first. Can you please tell us about that decision?
Yeah, when I was doing study at medical school, one day I went to the library, and then I'm looking the journal papers, and I found a very interesting paper, and which is about the small electrode embedded in the arm, and for the people who lose the for example arm, so it's a kind of electrode to sense the activity of the nerve to control the
Prosthetic limb?
Yeah. And that paper was written by Professor Esashi of Tohoku University, and using a silicon micromachining technology and a small silicon chip with many holes, and FET is placed in this, and I was very much surprised and attracted in this technology. So that is my starting point of MEMS.
Yes, I was going to ask you that. So you have a very clear memory of your first MEMS experience.
Yeah.
And that was it. Fascinating. So you discovered that as a master's student. But again, instead of deciding to go get a PhD immediately, you decided to go to industry. Can you tell us more about that decision?
And because I found that paper and I talked to my professor, I found this, and this is very, very, very great. And then my professor said, I know a person who are doing similar research with this, and I can introduce him to you. Okay. Then I said, please. And then that person is Mr. Igarashi. Igarashi is the person working for Toyota Central R&D Lab. So that is my first step. Get to know Mr. Igarashi, and he is called as a father of sensor in Japan, and he invented the piezoelectric resistive pressure sensor in Japan. So I met him, and I was further fascinated attracted with silicon micro fabrication technology. So that's why I finally decided, okay, I joined the Toyota Central R&D Lab and do silicon micromachining research.
Fascinating. What were some of the major projects that you worked on during your 15 years at the Toyota Central Research and Development Laboratories?
My first research theme is flow sensor, silicon flow sensor. And the final goal is for measuring the blood flow of the body by placing the silicon flow sensor on the tip of the catheter. So catheter tip silicon flow sensor is my research goal. And I work for that about 5-6 years. And then I also do the research related to automotive sensors, something like acceleration sensor, because that time, the 1980, it's time to use the silicon micromachining technology to develop the it's for protect the passenger airbag. Yes, airbag G sensor. And then the later the angle rate gyro sensor, and also infrared ray sensor, and so on and so on. And also, of course, the first one for the automotive is pressure sensor, silicon piezoresistive pressure sensor, then acceleration and gyro and infrared ray, non-cooled, uncooled infrared rate sensor. Those kind of automotive sensor is also my research field.
I see. Now, you had that exposure to MEMS technology as a master's student and then did micromachining research at the Toyota laboratories. Can you tell us about your first MEMS conference? What was that experience like, the impression it had on you?
Well, my first presentation at the international conference was this conference, which I'm now attending, Transducers 1987, held at Tokyo, and that was my first time. And I present my silicon flow sensor, and I got to know several friends. For example, Goran Stemer. I still communicating with him, and also, that is my first international conference related to MEMS.
I see. Now, after working in industry for about 9 years, you decided to pursue your doctorate, finally. In fact, as I understand, you managed to do both at the same time, working industry and working on your PhD. Can you tell us why, after 9 years, you decided to get your PhD, and how did you manage to do both successfully at the same time?
The Toyota R&D laboratory is an independent company, not the part of the Toyota Motor. It's an independent company, and they work for the Toyota Group companies, including Toyota or Denso and so on and so on. And usually at the company research division, the researchers, when they are young, they are working as a researcher. But when they are getting elder, then many of them are moving to the management or moving to the development or something like that. So research division, only the young people and also the good managers. But because Toyota Center R&D is an independent company, so once you start to be a researcher, you have to be researcher for the last. But my another professor advised to me, you should not stay there until your retirement, because if you are getting elder, maybe it's very difficult to compete with young people, something like that. So you should not stay there. So I thought, yeah, that makes sense. So I was thinking, okay, I will quit R&D, Toyota R&D sometime later. So to quit and then change to maybe somewhere, maybe it's better to write papers and have a good achievement. So I continuously try to write the paper for the journal or present my achievement at the international conference. So, and when I was 1991, I was recommended from one of the division manager, why don't you go back to your, go to the PhD course offered by Nagoya Institute of Technology, my previous university. They are looking for a good PhD candidate, but you should stay here and work weekday, but go there weekend, and then try work hard 3 years, then you may get a PhD. So I thought, okay, maybe I tried a lot to write many papers, but maybe it's time to go the PhD program, and then get PhD is the easier way to change my career. So that's why I decided to go to the PhD program on weekend, and then spend 3 years, and I got my PhD. It was 1993, and then after, maybe I have several reasons why I changed from industry to academia. May I start to speak this?
Right. Yeah, I was just going to ask you about that. You spent, I think, another 3 years in industry, but then in 1996, you
1996, yes, yeah.
transitioned and became a professor at Ritsumeikan
Yeah.
University. Yeah. Well, how did that happen? And
Yeah, because if you are working at a company, the major important part is, as a company employee, you have to make a profit for the company, or you have to do the research which makes the profit to the company. And what if you want to do something new project? If you want to start something new project, to get, you need the permission, approval from the company. No, from the company. But to get the permission, there are two effective way to explain what you want to do. One is, this research or this project is very, very promising, because if you do this, then this comes, and then this comes, something like that. So you will not fail. This will be 100% sure to be successful. This is one very effective way to persuade to start project. The another way is, this project is already done by that guy. It may be the competitor of the company. So we should start now. That is another way. But both are not attractive for me, because if you don't fail, then anyone can do that. So why me? And then the second one, if someone done it, why I need to do that? So it means, if you want to start some project which is some risky or not known to success, that attract me. So I cannot do the project I want to do, because I cannot explain very, very well to the company director. This is very risky, but I believe I can do it. But I cannot explain why this is very, very successful. But I believe I can do it. Or nobody do it. That's why I want to do this. Something like that. So I am very much frustrated about the company research life. So that's why I moved to academia. I need freedom of choosing the topic.
I see. And that worked out well for you. You enjoyed being a professor and having students doing research while you were at Ritsumeikan University for several years. But after several years, you decided to move to Kyoto University. Oh, what prompted that change?
Well, that time I was asked, the one professor of Kyoto University, I want you to join us. And I think our department needs this research field, so I want you. But I cannot assure, so please apply to this position. But I cannot assure we will accept you, because the decision is made by the committee. So I cannot assure, but I think we need you. And then I thought, okay, let's try it. Because Kyoto University is known as a top university in Japan, and I was asked to come because they need me. So why not? But at the same time, Kyoto University has some kind of a clear mentality of they think the academic, say, deep academic understanding for dedicated specific field is very important. Do you understand what I mean? But MEMS is a kind of field such as not deepen a specific field,
And narrow.
narrow, but more like the synthesis something by combining several ideas and then make assemble in the most appropriate best way to realize something new. So in that sense, analytic approach is the conventional Kyoto University approach. But my MEMS field is something different. It's a synthetic approach of something new. So, that professor who asked me to apply say, please make your presentation fit to the criteria of Kyoto University, so deepen a specific field, the analytic approach. But I thought, okay, that is not my style. So I did my presentation based on what I'm doing now. So, and if they don't like me, okay, it's your choice, it's your decision. I'm doing this in this way, and I think in this way. So I did my presentation, not fit to their view, but I did my presentation as I like. And finally, they decide to accept me. So that's why I joined Kyoto University.
I see. Actually, can you tell us a little bit about your early research as a professor at Ritsumeikan that was so broad?
At Ritsumeikan, okay, I should explain from the Toyota Center R&D. At the Toyota Center R&D, the company provide the good silicon fabrication facilities. So I can use those facilities, and I can also make CMOS and integration of sensor and the CMOS, so on, so on. But at the university doesn't have such kind of nice facility. So I forced to change my research topic. So, but luckily, the Ritsumeikan University has a synchrotron. And that time, the legal process is one of the very, very attractive process. So I started to work on synchrotron to apply for some new microfabrication technique. So something like relay, similar to Liga, but I add some new idea. So usually for the exposure step, the mask and the substrate is fixed, something like that. But I intentionally move the mask during the exposure to make the very complicated 3D structure on the substrate. And that is one. And also I apply that technology for the bio device, something like the electrophoretic device for DNA analysis, something like that. So I started something new research at Ritsumeikan.
I see. And then you were at Kyoto University for 15 years.
Yeah, 16 years.
16 years, continuing to do research in this area. Can you, when you look back at your research activities, are there any projects that stand out as things you're very proud of, or would you like to share?
Well, at Toyota, I have been working for 15 years using the advanced silicon micromachining technology. And at Ritsumeikan, I started the new technology using X-ray lithography. And so I know a lot about the so-called top-down technology based on silicon microfabrication. But that time, I'm changing from Ritsumeikan to Kyoto University, I'm thinking, maybe I need to start something new, because I know a lot about the advantage of microfabrication, but also the limitation of the silicon microfabrication. And there are a lot of space and at the further smaller scale, and different approach for that area. not silicon micromachining, but something else. And I have been thinking what kind of possibility there are. And finally, I came to the idea to use DNA. DNA also. Later, I understand the approach I was attracted is so-called DNA nanotechnology, but at that time I didn't know that. And that technology is so-called bottom-up technology. Anyway, I was very much attracted to DNA, and then first I started to use DNA as an intelligent adhesive. Intelligent adhesive means adhesiveness can be controlled by the environment. And then it's advanced, the progress, and I started to know the more complicated application of DNA, so-called DNA nanotechnology, including DNA origami technique, and so on. And what I'm doing that time was make small components by maybe silicon micromachining or some nanoparticle technology, and then modify the surface by silicon DNA, and then control the binding between components. The components can be several different types of components, and by controlling the binding of different components as you designed, then you can make a system by using several different components, something like a Lego block of submicron scale or further lower nanoscale microblock or nanoblock. So that is my research at Kyoto University.
Fascinating. Now, again, after 15 years of doing cutting-edge research, you decided to make another significant career change.
Mm-hmm.
This time, you decided to take an academic leadership position and became the founding dean of the Engineering and Graduate School of Engineering at Kyoto University of Advanced Science, a different institution, as well as executive vice president. What led you to make that decision?
Well, I was Kyoto University professor, and many people think Kyoto University is a top university in Japan, and I was professor, and I have a good students and a good colleague. I'm feeling that I'm step up. Now I'm come to something like the top of the stairs, and then I have some kind of feeling that what is the next step, and I'm slightly losing some kind of my goal. I'm a kind of here at the top, but I'm looking for some new steps to go, and maybe I am a bit frustrated about that situation, and I'm looking for something. I didn't know what, but I'm not satisfied that situation. And that time, by chance, I was asked, why don't you make a new engineering school at this university? They don't have engineering school, and the person who wants to start engineering school wants to have very unique engineering school which accept half international students and teach all the lectures in English. Oh, that's very tough work. But finally, I decided to accept because I find the next stairs to go up, and the field of that engineering school is mechanical and electrical system engineering. So MEMS is mechanical, electrical, micro electromechanical system. So the size is different. MEMS is small size, but department handle all the scale across small to large. But the interdisciplinary research in terms of the research field, it's the same. So I think I'm the best person to do this.
I see. Fascinating. Going back to the research a little bit, looking forward, what challenges and opportunities do you see in the field of MEMS and miniaturization that you're the most excited about as of today? Are there anything out there that seems particularly exciting or challenging?
What kind of direction?
Yeah, future directions. For the field. Do you have any?
Well, that's a very very difficult question to answer easily. But at least I believe silicon microfabrication is already, in a sense, matured. Of course, there is space to go further, and also now the bottom-up technology is somehow close to maturing, but not yet. But it's further to go, and also in between. So far, there is not good overlap, and top down is yes, and bottom up is yes. But by fusing those two approaches, there are more spaces to develop and to go in the future, and I think that is the another open field for the person to go. And I thought when I started the DNA nanotechnology research, I thought this field progress more fast, but actually it's very slow, because I understand that the DNA nanotechnology is very different from silicon micromachining. So some kind of common sense of silicon micromachining is not applicable to DNA nanotechnology, and maybe vice versa. So it's very difficult to understand both fields. But by understanding the both fields and try to develop some kind of missing field of fusing of two fields, has a lot of possibility. And I think we need the person, young person, not like me, but the young person who are interested in this field can make a big progress.
Yes,
and innovation.
So taking that further, if you were a student today, which area of study or research topic do you think you would pursue? I guess perhaps what you were just describing, but maybe there's other exciting research topics, that if you were starting over as a student, but existing with today's mature technologies or opportunities, what do you see for, if you were advising a student today, which areas to consider research?
Well, maybe I can say in this way. When I started the MEMS research, it is very, very new. So anything what I tried is new. So it's very exciting. Even the young people can have a kind of leadership of a specific research topic. So I enjoyed very much about that. And if you started something like the establish the field, it's very difficult to take leadership. The young people take leadership is very difficult. But MEMS was so young and nothing there. So everything you did is evaluated by the other people, and the other people say, oh, that's nice, something like that. So I was very, very motivated. So I would like to recommend young people to find such kind of field. And the question is, where is that field? it's very, very difficult to say this field, but Definitely, that the field I mentioned, the in between top down and bottom up, that kind of fused field has a lot of space to do, and also, as many people know, for example, AI is developing faster and faster, and this power of the AI to analyze a huge amount of data and find some kind of truths from the amount of huge pile of data also creates something new possibilities. So may that approach of the fused field of top down and bottom up can be use the AI as a very powerful tool to develop. So it's so difficult to start everything at the same time. First, you may need to learn, for example, DNA nanotechnology, and then add some kind of knowledge of AI, something like that. But move step by step and acquire knowledge and experience which only you have. So not only one field, but several fields, knowledge and experience. Then it makes you something like very unique, not comparable with other people. And then that kind of your own experiences and knowledge will make you something different from others. So there is no simple field, okay, this field. But by learning several fields first and then try to make to combine and focus on that field of in between top down and bottom up would be very attractive and promising, I believe.
I see. Thank you. Today, do you have any hobbies or activities you like to do outside of your work? I mean, when you were a kid, you talked about amateur radio and these other things you like to do. But now, as an adult, are there any hobbies that you enjoy?
Frankly saying, I don't have a hobby. I thought I should have a hobby, and I tried several times, for example, tennis or canoeing or how to say, sailing. But and also if I have time, I want to learn cooking. But now my hobby is my job. So what I'm doing is my hobby. Because I'm enjoying to spend my time for developing the new program and educate people and stimulate students. This is a very interesting hobby for me. So now I thought I should have a hobby, and maybe I should have something to say when you are asked, what is your hobby? I have this. But I gave up that idea, and I'm proud of saying my hobby is my work.
I see. Thank you. Well, Professor Tabata, thank you again for taking the time to be with us today and sharing so much about your impressive career in the field of MEMS.
Thank you very much for asking a lot of interesting questions. And I don't know, my answer may help you to think something, but I hope anybody, young people can think and do what you want to do. The most important thing, I think, is find something interesting for you and then go to that direction deeper and slightly wider and deeper. So concentrate on what you want to do.
Follow your passion.
Yeah, follow your passion. Yes, follow your passion. Thank you very much.